You're floating here, weightless, wrapped in the soft pulse of the life support system. The sound is steady, almost like a slow heartbeat. Through the viewport, a distant nebula glows, a quiet reminder of how far you've come and how much farther you still want to go. You've always felt that pull to reach those specks of light, to stand on worlds no one has touched. And you know that the ships we use now are only the first steps. To cross real distances, you'll need something stronger, something almost impossible. Drives powered by starlight itself, engines that stretch the limits of what humans can build. These ideas drift through your mind the way they drift through every late-night conversation about the future of space travel. You've heard many of these ideas before, half-formed sketches, bold theories, quiet rumors from engineers who dream a little bigger than the rest. Tonight, as the ship settles into its slow, steady glide, you'll explore them one by one. Some exist only on paper, others are taken seriously by scientists. A few belong to that strange borderland between real physics and the edge of science fiction. But all of them share one thing. They hint at how we might travel farther than we ever imagined. You don't need to memorize anything. Just let each idea unfold as we drift from one possibility to the next. Even the basics, the rocket equation, specific impulse, feel calmer out here. They're not just technical terms. They're the quiet rules that shape how anything moves in space. You can follow along, or you can let it all wash over you like a long, slow dream. Settle in with a warm drink if you like. Sarah will help guide the transitions, marking each new concept with a soft cue so you can glide in and out of this journey at your own pace. When each section ends, you'll hear a small cluster of related ideas, gentle signposts pointing to whatever might spark your curiosity next. And occasionally, we'll even gently remind you of past journeys we've taken together. Perhaps a fleeting image of that older episode's cover art shimmering briefly in your mind's eye. We've had to gently merge a few topics, you see, as the sheer abundance of cosmic ingenuity sometimes nudges similar concepts together, especially when we resist diving into the intricate technicalities that might disrupt our calm, immersive flow. And, truth be told, as a humble physicist rather than an aerospace engineer, there are a few concepts where even I, at times, find myself simply lost in quiet awe, nodding gently as if understanding every nuance. It's a common jest, isn't it, that rocket scientist is synonymous with profound intellect. It's important to remember, as we float through these marvels, that virtually every single one of these profound ideas, whether from a visionary scientist, a captivating sci-fi author, or often both, began as someone's brainchild. For the sake of brevity, and to keep our journey flowing peacefully, we won't delve into the full, rich tapestries of the creators' lives or the detailed histories of their devices, even when a drive bears their name. This means brilliant minds like Mark Millis, who gifted us with an array of hypothetical drives such as the bias drive, the diametric drive, the disjunction drive, and the pitch drive, aren't getting nearly the credit they truly deserve today. Even in this long, contemplative drift, so much remains unsaid, so much mind-bending science, so many fascinating developmental stories, and breathtaking science fiction narratives wait to be discovered by those of you who choose to journey beyond these brief entries. Should you feel that gentle pull to explore deeper, to truly understand the whispered secrets, I gently recommend the guiding lights of these drives. The Gyo recommend the guiding lighting Cero, the Tau, Sinoi, Domic rockets, Centauri dreams, Orion's arm, and of course S's Emsons, Ennis gag. Now, with all that said, and without another moment's gentle delay, let us begin our quiet exploration. Alcubierre Drive, first, on our gentle drift, let's consider the Alcubierre Warp Drive. Imagine, if you will, the very fabric of space and time, not as a rigid, unyielding canvas, but as something pliable, something you could gently sculpt. This ingenious concept suggests using hypothetical negative matter or a strange form of negative energy to create a ripple, a local distortion around our vessel. You'd find the space ahead of the ship gently contracting, while the space behind us would subtly expand like a silent, invisible wave, perhaps reflecting the distant starlight in ever so slightly distorted patterns on your hull. The marvelous thing about this approach is that the ship itself wouldn't actually be accelerating within this bubble of warped space. You, nestled comfortably inside, would feel no G-forces, no sudden jolts, just the familiar, soft vibration of the ship's distant machinery through the floor. You'd simply be riding the wave, a serene journey. This ingenious trick not only allows for incredibly high speeds, but also elegantly bypasses the normal speed limit of light. Much in the same way, the mysterious dark energy and the vast Hubble expansion seem to operate across the cosmos. A true marvel, isn't it? Breaking the cosmic speed limit just by bending reality. But there's always a catch, isn't there? This vision, while breathtaking, relies on exotic matter that for now remains purely hypothetical, a whispered possibility rather than a tangible reality. Because of this requirement for the unknown and its promise of faster-than-light travel, it's often classified as Clarkatech, a technology so profoundly advanced, so far beyond our current grasp, that it borders on indistinguishable from magic. It creates a bubble of warped space around the ship, a concept that feels wonderfully similar to an induction ring drive, another fascinating whisper in the cosmic wind. We've explored the very idea of warp drives before, haven't we? Such beautiful, impossible dreams. Antimatter, rocket, Now, let's consider something with a different kind of quiet power. The antimatter rocket. You know how every coin has two sides. Well, matter in our universe has its opposite, antimatter particles with the same mass but inverse characteristics. Picture an antiproton meeting a proton, or an anti-electron, which we call a positron, encountering an electron. In that fleeting, silent moment of contact, they don't just cancel out, they annihilate each other, transforming their entire mass into pure energy, typically in the form of a pair of photons. It's not inherently explosive. It happens often enough in the quiet corners of the universe, and even within your own body, as certain particles decay, then rapidly find their opposites and vanish, leaving no trace. But in vast, controlled quantities, the energy released is simply staggering. Imagine, if you can, a single kilogram of antimatter gently meeting a kilogram of ordinary matter. The resulting release of energy would be equivalent to a 43 megaton hydrogen bomb, dwarfing even the infamous Tsar Bomba, that colossal device that once shook the earth, yet weighed a staggering 27,000 kilograms. Here, with just 2 kilograms, you unleash that same force, a gentle whisper of power, isn't it? What's more, this method has a beautiful simplicity to it. Once you have the antimatter, it requires virtually no complex moving parts, just clever magnetic fields to contain it within the softly glowing console lights. The true challenge, of course, lies in creating it in meaningful amounts, and then holding onto it without it annihilating with anything it touches. Always a catch, isn't there? But imagine it's solved, magnetically spraying a precisely equal amount of antimatter and mundane matter into a nozzle, creating a photon rocket. Its exhaust velocity would be nothing less than the speed of light itself, pushing you forward on a beam of pure energy. Whispers of vessels like the theoretical Valkyrie spacecraft speak of this incredible potential, a power born from nothing more than the gentle touch of opposites. Imagine, for a moment, that you are here with me, drifting gently through the inky canvas of interstellar space. The subtle hum of our engines, a soft lullaby against the quiet thrum of the cosmos. We're talking about journeys that truly redefine distance, voyages powered by the most exquisite, almost mythical energies. Think about pushing the boundaries, getting so close to the speed of light that time itself begins to stretch and ripple around you. If we could harness antimatter in its purest form for propulsion, you could experience a mere 10 hours of ship time for every full day that passes back on Earth. Perhaps just 40 years of your own lived experience, while an entire century unfolds back home. It's an almost dizzying thought, isn't it? The universe truly has its own peculiar sense of timing. Yet this incredible power, this ultimate rocket fuel, remains tantalizingly out of reach in its vast quantities. Antimatter is notoriously shy in nature, a fleeting whisper that's incredibly difficult to coax into being and even harder to contain. So, we dream of more delicate applications, more artful ways to coax its potential. Perhaps we wouldn't need a full tank, just a tiny, precious spark. Consider, for instance, the elegant simplicity of an antimatter ablated light sail, a concept that allows us to use this rare fuel with almost frugal grace. You might picture a delicate yet immensely strong dish-like sail, perhaps just a few meters across, unfurling ahead of our vessel. Within it, a whisper of anti-hydrogen, mere grams of this ethereal substance, would be carefully released. A delicate mist aimed at a forward plate made of something robust like uranium-238. The resulting reaction, a soft, controlled burst of energy, would send a cascade of neutrons streaming away from the sail at incredible speeds, providing a continuous, gentle push. It's like catching a silent cosmic wind, isn't it? We could even gather these precious antimatter particles from the swirling atmospheres of distant gas giants, a poetic harvesting of the universe's own bounty, feeling the faint, continuous acceleration through the ship's hull. Or perhaps we might opt for a more contained fire, a fusion reaction sparked by the briefest touch of antimatter. We've been tirelessly pursuing controlled fusion for generations, and this method, antimatter-catalyzed fusion, is one of the most promising avenues. Imagine a tiny speck of antimatter, a nearly invisible trigger, unleashing a torrent of fusion energy far greater than its own mass. It's believed to be a remarkably straightforward process, a tiny key unlocking an enormous power source. This controlled blaze could run our ship's power systems, perhaps fueling ion drives that hum with quiet purpose, or even provide precise microfusion pulses directly behind us, giving us a powerful, steady shove through the void. You'd feel that deep, resonant thrum of contained power beneath your feet. Even if we can only manage to produce and store antimatter in very modest quantities, not enough for a pure antimatter rocket, this catalyzed fusion could still enable a fusion torch drive. Picture a focused beam of superheated plasma pushing us forward, a continuous, shimmering tail extending behind our ship, allowing us to exceed 10% of light speed with a beautiful, controlled burn. You'd sense the consistent, powerful thrust, the slight, exhilarating pressure, the slossily exhilarating pressure pushing you gently into the distant stars beyond Tencent dollars and Sully and supplement with the eye and the prully and the plan with and we play and I and where to you and have a game I went I took to cook work to earn it to about to with it papa what took it to you what to good at God you the good us you would if you what I'm bigger this but if it was to good up you you could do it that must that if I will with the life of then if instance now let's step away from the theoretical and touch upon something a bit more present. Smaller vessels, perhaps the nimble scouting craft we sometimes see zipping between asteroid belts, often employ what's called an arc jet rocket. It's wonderfully simple and effective, a workhorse of the void. You might hear its faint, high-pitched whine from time to time, a sound that quickly fades into the background hum of the ship. Essentially, it uses a pair of electrodes to create an electric arc, much like the arc welders you might have seen on construction sites, which then superheats and vaporizes a propellant like ammonia, turning it into plasma. This blazing plasma is then accelerated backward, giving the ship a quiet, consistent push. It's not about sudden, dramatic bursts of speed, but rather a steady, patient accumulation. You feel a gentle, almost imperceptible force, a continuous nudge rather than a powerful shove. The exhaust velocity is incredibly high, more than double that of a traditional chemical rocket, making it very efficient for long, slow journeys. There might be some minor upkeep with the electrodes, a periodic maintenance task, but nothing to worry about in our cozy ship, of course. But what if you didn't need any fuel at all? What if you could simply fall? This leads us to the utterly mind-bending concept of a bias drive, something so advanced it borders on pure magic, what we affectionately call Clarkatech. Imagine a ship that doesn't push against space, but rather subtly changes the very fabric of reality around itself. It's like gently tweaking the universe's rulebook, specifically the gravitational constant, making gravity slightly stronger in front of you and slightly weaker behind you. You would, quite literally, just fall to your destination. The feeling would be one of incredible, effortless drift, a silent, almost dreamlike motion where you're simply drawn forward without a single spark of propulsion. No fuel expended, no violent thrust, just a gentle shift in perceived weight as the ship subtly reconfigures the local laws of physics. Of course, we don't yet have the slightest idea how to actually do this, and there are theories about singularities appearing right at the ship's core. Nothing to worry about, probably, but the sheer elegance of merely willing yourself to move without expenditure is a concept that sparks a quiet awe, isn't it? Just imagine. Then there's the truly audacious idea, one that speaks to humanity's endless fascination with the most extreme phenomena, the black hole drive. This isn't about avoiding the universe's monsters, but about taming them, drawing power from their immense, crushing gravity. You could envision a ship that carefully approaches a naturally occurring black hole, using its powerful gravitational pull to slingshot across vast distances. Or, more daringly, imagine a tiny, contained micro-black hole, no bigger than a mountain, tethered to our vessel by powerful magnetic fields, humming with a deep primal energy. You'd feel a profound, low vibration, the resonant hum of the magnetic containment fields fighting against the universe's ultimate destroyer. We could absorb the high-energy radiation emanating from its event horizon, much like catching sunlight, converting that raw power into propulsion for a photon rocket, a beam of pure light pushing us forward. Or even use pairs of these domesticated cosmic beasts to accelerate our ship in an endless gravitational ballet, looping around them to build incredible speeds. The sheer audacity of it, domesticating a black hole for travel, isn't that just like space, always pushing the limits of what we can imagine? And finally, consider the elegantly simple, yet profoundly ambitious, Bussard ramjet. The vast stretches of space, though appearing empty, are actually subtly filled with ionized gas, mostly hydrogen. Imagine our ship extending an enormous, ethereal, magnetic funnel, an invisible net hundreds, perhaps even thousands, of kilometers across. As we travel, this field would gently scoop up these interstellar particles, drawing them in like a cosmic vacuum cleaner. You'd feel a faint, almost imperceptible drag, a soft resistance as our ship continuously ingests the very fabric of the void. This collected hydrogen would then be compressed and fed into our fusion reactors, becoming the very fuel that sustains our journey. It's the ultimate self-sufficient explorer, a vessel that drinks from the ocean of space itself, forever replenishing its reserves. A quiet hum of the magnetic collectors, a sense of infinite potential. Just you, the ship, and the boundless universe, forever sustained by its embrace. As we gently drift, you might wonder about the ultimate fuel source, the dream of endless propulsion. Picture, if you will, the elegant concept of a Bussard ramjet, a ship that breathes the very essence of the void as its sustenance. Imagine magnetic fields extending far ahead of us, silently gathering the sparse interstellar gas, compressing it, heating it to incredible temperatures, much like an ancient air-breathing jet. But here, the fuel ignites itself through fusion, propelled by the sheer speed of our passage. The hum of such a system, if it were truly operating at relativistic speeds, would be a deep, resonant thrum through the hull, a symphony of captured stardust. It was a magnificent vision. You see, a vessel sailing an infinite ocean of diesel fuel, never needing to resupply, just accelerating forever. Isn't that just like the human spirit? Always striving for the impossible. You might recall tales of ships that chased the very edge of forever, like those in old classics. But the universe, as it often does, had other plans. The complex dance of physics, when calculated precisely, showed that for true, indefinite acceleration, this elegant solution simply wouldn't yield the energy needed. In fact, it could even slow you down. A touch ironic, wouldn't you say? Perhaps the dream was too grand. Yet, every good idea finds its purpose, doesn't it? While not an infinite accelerator, this gas-scooping method found its true calling in deceleration. Imagine arriving at a distant star system, pushed to incredible speeds by immense laser sails, then flipping around. Suddenly, those same magnetic fields become a giant brake, allowing you to slow down almost effortlessly, absorbing momentum from the interstellar medium, the soft vibration through the deck, a gentle tremor as the ship bleeds off velocity, feeling the void push back. It's an elegant partnership, a perfect dance between getting there fast and stopping with grace. Beyond deceleration, This magnetic gathering technique is incredibly useful for vessels with more modest ambitions. For those enormous freighters, deep space miners, or silent patrol craft, perhaps only needing to move a few % of light speed, scooping up ionized particles offers a continuous supply for their conventional fusion reactors. The console lights around us might flicker with the energy being processed, recycled air whispering softly as these behemoths maintain their station, effortlessly replenishing their power. Or consider those vast beaming stations, silently projecting energy or matter across unimaginable distances. They need constant fuel for station keeping, and the void provides. It's a quiet, persistent energy, always there. And if you happen to carry a tiny, contained black hole within your ship's core, quite a thought, isn't it? Then scooping matter directly into its hungry maw becomes a rather efficient way to power things, too. Of course, you must respect the physics. You can't scoop faster than your system's exhaust velocity, or you'd just be fighting yourself. But for giant carrier ships, perhaps needing to subtly shift direction, or to power the launch of smaller, faster vanguard craft with a focused energy beam, this subtle collection of matter offers a continuous, quiet stream of power. The universe, in its own way, always provides for those who know how to ask. Speaking of asking the universe for a lot, let's widen our gaze even further. Have you ever considered ... moving a star? It sounds like something only a deity could contemplate, yet the concept of a Kaplan thruster proposes just that. Imagine billions of tiny sun-facing mirrors, statites, delicately positioned around a star, concentrating its immense solar energy. You might need a moment to just float here, letting the sheer scale sink in. These focused beams then ignite targeted eruptions of solar wind, shaping it into a directed stream, pushing the colossal star ever so gently. This incredible outpouring of energy would then pass through an enormous, almost incomprehensibly vast, buzzard ramjet-like assembly. Can you feel the shift in gravity, the subtle pull of such immense forces, even just in thought? This grand apparatus would funnel streams of oxygen-14, creating a colossal jet that pushes the entire star, slowly but surely, across the cosmos. It's an astounding feat, far beyond simple Shkadov thrusters, a galactic-scale engineering project, orchestrating the movements of celestial bodies. The very fabric of space would ripple with the effort, a silent testament to the audacity of thought. From moving stars to something a little more grounded, shall we say. Before the whispers of magnetic fields and stellar engines, there was the fiery heart of the chemical rocket. These are the workhorses of the cosmos, the roaring giants that first punched holes in the sky. Think of those classic launches, the sheer, visceral power of combustion, fuel meeting oxidizer in a brilliant, furious embrace, creating a scorching stream of propellant, that intense, incandescent flame, a beacon against the darkness, pushing with an incredible momentum, propelling the ship away from a planetary embrace. You can almost feel the deep thrum of it, the shuddering power, even now, can't you? This raw, explosive energy is what grants a spacecraft the sheer push needed to escape a gravity well, to clear a thick atmosphere. While other, more efficient drives might eventually reach incredible speeds out in the deep void, they could never lift themselves from a planet's surface. Chemical rockets are direct, forceful, and because of that, they perform best when run as hot as their resilient bodies can possibly withstand. Nothing to worry about, probably. The most efficient of these, a volatile ballet of molecular hydrogen and oxygen, is difficult to handle. A wild spirit, so often we rely on its calmer, more common cousin, a refined kerosene, essentially. Yet, there's a quiet ingenuity in adapting. Imagine sourcing your fuel from the very moon you're landing on, or from the dusty plains of Mars, producing it in situ for your return journey. It's a subtle shift from carrying all your needs to finding them waiting for you, a testament to resilience and resourcefulness in the quiet vastness of space. Now, let's venture beyond the plausible, beyond even the fantastic, into the realm of what some simply call Clarkatech. This isn't a propulsion system itself, but a category for ideas so utterly advanced, so seemingly impossible with our current understanding, that they feel indistinguishable from magic. You see glimmers of it in the deepest, most speculative corners of thought. Propulsion that manipulates gravity itself, perhaps even bending space-time in ways we can barely camberies, creating a universe where a serita fifru and 300 of us, so pu kienda kriend kufrio kriend you prind kun and do and you would of begin vibe to go you can talk to be to with a what to a paper the bit of part and you spec what I'm beautiful I was a dice that death if you give but that's to do that but if I were my views why does the universe always do this to you, presenting such tantalizing mysteries? Imagine ships powered by negative matter or other exotic substances, silently appearing and disappearing in flashes of impossible light. Or perhaps systems that ignore the very speed limit of the cosmos, dancing beyond light itself, or creating stable portals to other dimensions with different laws of physics. The faint hum of your own ship, always present, suddenly feels almost quaint in comparison. These are the whispered dreams of physicists and poets alike, technologies that might, one day, alter the fundamental constants of reality around us, allowing us to fold space, traverse unimaginable distances, or simply conjure a perfect, perpetual motion. It's a breathtaking thought, isn't it? The universe holds so many secrets still. As you drift here, suspended in the cool touch of recycled air, gazing out at the star-dusted velvet beyond the viewport, a faint, rhythmic thrum vibrates gently through the deck plating beneath you, the ship's pulse. We're moving, of course, but it's not always with the roar of traditional rockets, is it? Sometimes, the universe offers more elegant, almost impossible whispers of propulsion. Imagine, if you will, a drive so subtle it seems to push against nothing at all, a quiet nudge from the fabric of reality itself. This is the realm of the diametric drive, a concept so audacious it borders on magic, yet grounded in the strangest corner of theoretical physics. Picture particles with negative mass, a peculiar thought, isn't it? Unlike everything you know, which pulls things towards it, these oddities are believed to repel both the positive and their own negative kin. So, if we had one of these elusive particles trailing behind us, it wouldn't draw the ship in. Instead, it would gently, persistently shove us away, a constant, effortless push. It's like being carried by an unseen current, a gravitational whisper rather than a shout, making the ship feel like an enormous, weightless airfoil gliding through an atmospheric ocean. The sensation would be minimal, perhaps a soft, continuous acceleration, barely noticeable, but always there, pushing you ever onward. Then there are concepts that simply bend the mind, making you wonder if the universe itself has hidden trapdoors. Consider the disjunction drive. What if you could take a field like gravity itself and simply unmoor it from its source? Imagine standing on a ship near a colossal black hole, its gravity undeniably pulling you. But then, with a thought that immense gravitational field is somehow detached from the black hole and re-anchored just ahead of your vessel. Suddenly, you're in a perpetual state of gently falling forward, drawn by an invisible, untethered force that's no longer connected to anything you can see. It's a dizzying thought, isn't it? A constant, almost serene tumbling toward a phantom pull, with the ship's internal gyros perhaps making micro-adjustments to keep you stable as you fall through the void. Perhaps we could even separate your inertial mass, that feeling of solid resistance, from your gravitational mass, leaving you incredibly light but still grounded. The console lights would glow softly around you, reflecting the distant starlight as the ship subtly a barely perceptible shift in gravity, a constant reminder of the strange forces at play. You might need a moment to just float here, letting your mind grasp the implications of such a fundamental disconnect from reality. Moving from the truly theoretical to the wonderfully ingenious, let's talk about catching the solar breeze. Our sun, and indeed every star, exhales a constant breath of ionized particles, a vast, invisible wind sweeping through its system. We could unfurl a massive gossamer sail, stretching for kilometers, to simply be pushed by this stellar current, much like ships once sailed the oceans of old Earth. But space is vast, and these particles are diffuse. Instead, we can deploy hair-thin conductive cables, like the delicate spokes of a cosmic wheel, that react electrically with these ionized particles. As these nearly invisible threads extend, forming a colossal, ethereal web, the gentle electric fields they generate interact with the solar wind, providing a subtle, continuous push. You might feel a faint, almost imperceptible drag, a whisper against the hull as the ship gains momentum. This method, while confined to the magnetic embrace of a star system, is perfect for accelerating us up to cruising speeds or gracefully decelerating upon arrival at a new stellar destination, conserving precious fuel. It's a serene dance with the star's own exhalation, a silent journey propelled by the very light it casts. And as we journey, our path often brings us close to the majestic, swirling magnetic fields of gas giants or even Earth itself. Here, another clever trick comes into play: electrodynamic tethering. Imagine extending an incredibly long, insulated wire, a tether stretching for many kilometers from our ship deep into a planet's magnetic field. By running an electric current through this tether, we can essentially push off the planet's magnetic field. Like rowing a boat against an invisible current, the ship gains thrust, a silent, powerful nudge, without expending a single drop of fuel. The sensation would be one of effortless gliding, a subtle hum of energy permeating the ship as it harnesses an unseen force. This technique is not just for propulsion. Reverse the current, and the tether can generate power, recharging our systems as we cruise. It's also incredibly useful for station keeping, or for helping larger structures, like orbital skyhooks, regenerate momentum, silently pulling themselves back into position after flinging a ship into deep space. Isn't that just like space? Always finding new ways to surprise us with its elegant physics, even around the most powerful magnetic fields of distant neutron stars. Finally, we arrive at a concept that once set the space community abuzz with whispered promises and furious debate: the M drive. For a brief, intoxicating period, it seemed to offer the ultimate dream, a thruster that could generate propulsion, without expelling any propellant. Imagine a sealed chamber, a simple metal cone, somehow pushing itself forward with internal microwave reflections, seemingly violating the fundamental law of conservation of momentum. It was a tantalizing thought, promising limitless travel without fuel, a truly magical journey through the stars. The excitement was palpable. Whispers of breakthroughs, tantalizing test results from labs, even NASA suggested it might be real. You might have felt a flutter of hope then, a vision of rapid, effortless voyages to distant galaxies. But alas, the universe, for all its wonders, is still bound by its elegant, unbreakable rules. The initial positive results were later attributed to subtle measurement errors. The elusive push from nothing never quite materializing under more rigorous scrutiny. The silence of the void remains, unbroken by its impossible hum, a quiet reminder that some dreams, however beautiful, must wait for a different kind of magic. You drift, almost imperceptibly, within the soft hum of the ship, the subtle tremor of recycled air whispering past your ear. On a distant console, a faint holographic schematic flickers, sketching out the ghost of a whispered technology. A dream, really, an internal engine of silent pushes, where microwaves bounce within a precisely shaped cavity, gently urging you forward without expelling a single particle into the void. Imagine a constant, effortless shove, promising far more thrust than even the most elegant photon thruster could ever hope to achieve with the same energy input. It's an almost poetic idea, defying the conventional, conjuring images of a ballet through the stars. A beautiful notion, isn't it? Though perhaps better suited for theoretical musings than for our current, grounded journey. Nothing to worry about. Probably. Our passage, however, relies on a more tangible reality, a fundamental truth etched into every star chart: exhaust velocity. It's the whisper of expelled particles, the precise speed at which spent energy streams away from our vessel, pushing us onward into the deep. Every tiny molecule flung into the indifferent blackness contributes its momentum, and in return, we gain an equal, opposite push. Think of it, a faster expulsion means greater efficiency, allowing us to traverse unimaginable distances on far less precious fuel. Most chemical rockets, relics of a bygone era, manage mere kilometers per second, a fleeting breath compared to the vastness ahead. This is our limit, isn't it? The elegant tyranny of the rocket equation, always demanding more speed from less mass. Yet, the universe presents its challenges. Imagine trying to contain temperatures hot enough to melt solid rock, or even starlight itself, just to make those particles flee faster. Most materials simply cannot withstand the inferno required. But human ingenuity, or perhaps necessity, finds a way. Magnetic containment fields shimmer into existence, holding furious plasma in check, or ion drives accelerate heavier particles to incredible speeds, bypassing the heat entirely. The console lights around you glow steadily, reflecting on the smooth, cool surfaces of the cabin. And then there's a simple, elegant measure, specific impulse. It's a quiet testament to a fuel's inherent power, telling you how long it could defy Earth's gravity, hovering motionless, a silent sentinel. A useful metric, don't you think? A whisper of potential. But what if the push didn't come from asterisk within asterisk, our ship at all? We might call that field propulsion, a delicate dance with the very fabric of space itself. Imagine a long, slender, electrodynamic tether unfurling from our stern, subtly interacting with planetary magnetic fields, gaining a gentle nudge with each passing orbit. Or a colossal electromagnetic catapult, a slingshot of pure energy, flinging us into the void from a distant moon, accelerating us far beyond conventional limits. These are the external forces, the subtle whispers of gravity or charged particles that could guide us, or even more speculatively, the hidden currents of vacuum energy. Wouldn't that be something? To simply ride the universe's own invisible waves, feeling the gentle shift in weight as unseen currents embrace our hull. And then there's the grand, whispered dream, the one that makes every stargazer's heart beat a little faster as the distant starlight reflects in your eyes, faster than light or FTL drives. Imagine bending space, not just traversing it. A warp bubble, perhaps, shimmering around our hull, carrying us across light years in moments. Or a fleeting wormhole, a shimmering tunnel through the cosmos, bridging unimaginable distances instantly. Hyperspace, tachyons, the stuff of legend and longing. Known science, in its quiet wisdom, often classifies this as Clarkatech, beautiful impossibilities requiring exotic matter, defying the very flow of time and causality. A delightful fantasy, though, isn't it? To leap beyond the cosmic speed limit, leaving the universe tangled in our wake. You might need a moment to just float here, contemplating such a breathtaking, impossible leap. At the very heart of every journey, however grand or humble, lies the question of fuel. It's the very pulse of our ship, keeping the delicate glow of the console displays alive, circulating our recycled air, and most importantly, granting us the power to accelerate or slow our passage through the silent expanse. For many, it's the controlled fury of chemicals burning with an oxidizer, a precise expulsion of energy pushing us forward. But the universe offers more exotic tastes. The steady warmth of a nuclear reactor, the patient capture of distant starlight by vast solar arrays, or even the tantalizing promise of antimatter, a universe of energy in a single drop. And then there's the whispered hope of no fuel at all, a silent, reactionless drive, forever propelling us, linking back to that earlier, distant dream. Now, imagine a drive so potent, so utterly fierce, it could turn mere hydrogen into a blazing river of propulsion, the fusion torch drive. Not quite the legendary torchip that incinerates matter entirely, but a close cousin, harnessing the sun's own power. Within its core, fusion fuel ignites at temperatures hotter than any star, contained only by intricate magnetic fields, converting that furious energy into a torrent of superheated propellant, usually via ion or plasma thrusters. It's a meticulous dance of raw power, transforming radiation and heat into electricity, then into pure, accelerating force. You feel a subtle vibration through the hull, an almost imperceptible rise in temperature within the cabin, reminding you of the colossal energy needed for such a feat. Yet, even this marvel has its quiet limits, a gentle hand on the accelerator. But the true torch ship, the one beloved by dreamers and engineers alike, pushes this concept further still. Imagine the fusion reaction asterisk, not asterisk, contained within a reactor, but occurring directly at the ship's stern. A colossal sustained flame pushing you forward with unbridled might. It's a direct, uncompromising surge of energy, a relentless shove that allows for truly blistering speeds and rapid acceleration, bypassing the delicate engineering required to protect the ship from its own fury. No internal melting, no erosive radiation to fear, just pure, unadulterated thrust, driving you through the void like a star in miniature. The legendary Epstein drive, whispered about in hushed tones across countless star lanes, perfectly embodies this magnificent ambition. A beautiful, powerful dream, isn't it? One that beckons us onward, deep into the tranquil, starlit expanse. Okay, so we've been gliding through the endless expanse, haven't we? Just another quiet moment among the stars, with the faint hum of our own engines, a lullaby against the cosmic silence. You feel that subtle vibration through the deck plating. That's the pulse of our journey, a reminder that we are indeed moving, even if the void outside seems utterly still. And as we continue our gentle drift, let's cast our thoughts further out, beyond even our comfortable velocity, into the truly imaginative realms of how humanity might truly embrace this vast, beautiful emptiness, pushing the boundaries of what's possible in propulsion. Imagine a vessel unlike any you've ever seen, shaped almost like a celestial dumbbell, gliding with an impossible grace. At one end, a sphere of what we understand as ordinary mass, familiar and solid, while at the other, something else entirely. A whisper of negative mass, a theoretical marvel that bends the rules of attraction. It's a strange dance, really. The negative mass is drawn to the positive, yet simultaneously pushes it away, creating a perpetual, accelerating chase across the interstellar medium. You'd be inside, feeling perhaps a constant, gentle pressure, as if leaning into a perpetual, soft breeze, knowing you're being propelled by a fundamental cosmic anomaly. It's an elegant, almost playful concept, isn't it? A ship forever chasing its own shadow, pulling itself faster and faster through the star fields. Such a light hugger, as they're sometimes called, could approach the very speed of light itself, a dazzling blur against the nebulae. The console lights would reflect off your relaxed face, perhaps a soft blue or amber, as distant galaxies slowly begin to smear into streaks of impossibly vibrant color. You wouldn't feel the crushing G-forces of acceleration. Instead, just that steady, almost imperceptible push to slow down. A simple flip, and the chase reverses, the universe drawing itself back into focus around you. It's a concept that playfully teases our understanding of physics. Does it break the rules, or just bend them in ways we're only beginning to fathom? Don't worry about it too much now. Just let the sheer audacity of it wash over you. And then there's the dream of gravitic propulsion. Isn't that just classic Clarketech? The quiet hum you hear now from our life support systems would be replaced by something far more profound, the subtle thrum of manipulated space-time itself. Imagine moving through the cosmos, not by pushing against it, but by folding it, riding waves of artificial gravity. There would be no jolts, no sudden lurches. You could accelerate from a gentle drift to near light speed in what feels like an instant, yet the recycled air around you would remain perfectly still, your coffee cup floating undisturbed. Why does the universe always demand such violence for speed, when perhaps it offers this elegant ballet instead? It's the ultimate comfort, this gravitic drive, circumventing the jarring physics of inertia. You see, normally, rapid acceleration is a harsh mistress, tearing at everything that isn't perfectly secured. But if you could simply fall into a manufactured gravity well, the force would embrace every single atom of your being equally. No internal stresses, no messy differential accelerations, just a smooth, seamless transition through velocities that would otherwise crush you. You might just float here, watching the distant starlight flicker across the viewport, feeling nothing but a profound sense of peace as the ship surges silently onward. A truly luxurious way to travel, wouldn't you agree? Now, let's shift our gaze to something a bit more colorful. Peeking from the stern of certain vessels, you might catch the mesmerizing glow of a Hall effect thruster. Picture it, a soft, ethereal plasma jet, a ribbon of light painting the void, its hue changing subtly with the trace elements of its propellant. It's a quiet power, this one, a gentle, persistent nudge rather than a mighty roar. The sort of drive that would slowly, inexorably push you across light years. Given enough time, you'd feel a barely there vibration in the deck, a whisper of magnetic fields doing their work, ionizing and accelerating particles with serene efficiency. It's not about raw power, you understand. A Hall effect thruster whispers rather than shouts. You wouldn't be escaping a planet's gravity with one of these. Oh no, not by a long shot. But once you're out here, among the stars, with all that time stretching out before you, its steady, unwavering push becomes utterly profound. Imagine gazing out, day after day, week after week, watching constellations slowly, subtly shift their positions. That distant red dwarf, barely a pinprick now, would gradually grow brighter, larger, pulled ever closer by the constant, patient effort of that beautiful, silent plasma jet. Nothing to worry about, just a quiet, determined journey. And finally, for the truly audacious, there's the whispered promise of a Hawking radiation drive. Envision, if you can, a ship propelled by a captured fragment of pure cosmic mystery, a tiny, carefully managed black hole, a singularity weighing perhaps 100 kilotons. It doesn't pull things in. Instead, it slowly evaporates, releasing a steady, potent stream of photons, a pure light engine firing silently into the abyss. You'd likely feel a subtle warmth emanating from the core, a low, constant hum from the containment fields, a powerful, otherworldly presence thrumming deep within the ship's shielded heart. It's a magnificent, almost terrifying thought, isn't it? To harness such a fundamental force of the universe for our own propulsion. The larger the black hole, the longer it lives, but the slower it gives up its energy. So, our theoretical vessel would likely carry several smaller, more energetic ones, each one a miniature cosmic beacon, silently radiating us forward. Imagine the AW, knowing you're traveling on the very decay of space-time itself, watching the distant galaxies wheel around you, propelled by a quantum secret, a quiet, steady push from a universe that continues to surprise us, even in its most extreme forms. Fascinating. ... And as we drift deeper into these concepts, you might feel a faint tremor through the deck plating, a subtle reminder of the vast energies at play, even in theory. Imagine, if you will, harnessing something as colossal as a *** black hole * itself, miniaturized just for us. These aren't just science fiction musings. Current physics whispers that tiny, managed black holes could power a vessel. Though, admittedly, it's a delicate dance at the very edge of what we understand, the kind of technology that makes you pause and simply marvel. The challenge isn't just creating one, but keeping it tethered, a cosmic pet on a leash, magnetically confined within the ship. And then there are the emissions, a relentless storm of gamma rays that pierce through everything. We can't reflect them, so the ship must absorb that raw energy, transforming it into a more manageable warmth before reflecting that away. Bigger isn't always better here. For a larger ship, you simply add more of these contained singularities, a fleet of mini-suns propelling you forward. Our journey continues, a gentle current guiding us to the *** helicon, double layer, thruster, asterisk, or HDLT. Feel the subtle shift in the ship's orientation, a slow pivot that brings a nebula's soft glow into your peripheral vision. This is a plasma thruster, a marvel of quiet efficiency. It works by exciting its propellant with radio waves, coaxing it into a superheated plasma that then rushes out behind us, pushing us ever onward. There are no moving parts to break, nothing to wear down, just pure, elegant physics. It's wonderfully low maintenance, isn't it? As long as the power flows and there's propellant to spare, this silent engine hums along, a testament to clever engineering. No fussy neutralizers needed here, no troublesome charge buildup, just smooth, steady acceleration, barely a whisper through the hull, letting the silence of space truly envelop you. But what if our ambitions stretched beyond merely moving our asterisk ship? What if we wanted to nudge a star? Imagine the sheer audacity. The Helios drive does precisely this. It's a variation on a grander theme, a cosmic sculptor. Instead of simply reflecting a star's light in one direction, this drive turns mirrors toward the star itself, igniting a focused stream of scorching plasma that erupts like a colossal rocket flame from its surface. You're essentially lowering the star's mass, creating a powerful jet stream. Think of the possibilities, guiding a colossal, volatile sun away from a populated sector, perhaps even extending its life as it sheds mass, or boosting a chilly red dwarf's surface temperature, creating a warmer, more hospitable, equatorial band for budding civilizations. It's a breathtaking thought, isn't it? Manipulating the very fabric of stellar evolution. Now, lean back, let the recycled air refresh you. We're about to consider something truly mind-bending. The hyperspace jump engine, you know, the kind of leap that defies every conventional notion of speed. This isn't just faster than light. It's sideways, travel. Imagine our vast universe as a sprawling map. Instead of painstakingly traversing every kilometer, you simply step off the map onto a tiny, pocket-sized version of it, instantly moving your finger from one point to another, then stepping back into reality at your destination. You bypass the immense distances entirely, diving into a congruent, perhaps smaller or faster dimension. The console lights pulse a little brighter here, hinting at the energy such a jump would require, and the immense unknown of what lies between realities. We haven't quite figured out how to survive that journey yet, or even find such a place. Clarkatech, indeed. Feel that subtle shift in gravity, a gentle tug that reminds you of the ship's constant dance with the void. What if, instead of bending space, we could bend mass. This brings us to the inertia reduction drive. Every object has a certain resistance to being pushed, an inertial mass. But what if we could temporarily reduce that mass? A 100-ton ship suddenly feeling like 10 tons. It would move with impossible swiftness, accelerating and decelerating in ways that would normally turn a crew into jelly. That's where inertial dampeners, often its twin technology, come in, protecting you from your own astounding speed. Picture a sudden brake, a complete stop from unthinkable velocity without a single jolt. Not only would it make for incredibly nimble travel, but collisions would become far less catastrophic. Safer space lanes, faster journeys, though one must admit, it does stretch the very definition of energy conservation. Finally, let's consider something perhaps more familiar, yet no less elegant. the ion drive, you've likely felt its subtle, persistent push. This is a broad category, encompassing any system that accelerates charged particles, ions, using electric or magnetic fields. It's not about raw, explosive power, but rather a gentle, unwavering push that, over time, builds incredible speed. Imagine billions of tiny, invisible projectiles streaming out behind us, each carrying a whisper of our momentum. The faint hum of these engines is almost imperceptible, a constant, soothing thrum beneath the deep silence of space. It's a testament to sustained efficiency, not a flashy sprint, but a steady, deliberate journey across the unfathomable distances, carrying us calmly deeper into the boundless cosmic ocean. You feel a soft, steady thrum beneath your seat, a barely there vibration that is the signature of our journey. This gentle caress of motion is often powered by something remarkable: the ion drive. Instead of explosive chemical bursts, think of a quiet, continuous push, an endless exhale of accelerated particles, propelled out the ship's stern by carefully shaped electric or magnetic fields. The tiny lights on the main console shimmer, hinting at the quiet power feeding our journey, perhaps from the vast solar arrays unfurled like metallic petals, or a miniature star contained within a shielded reactor deep in the ship's core. Even a battery, if the trip is short and sweet. Nothing to worry about, just steady progress. It's not about a violent shove to escape a planet's embrace. Oh no, not for these drives. They're for the long, patient haul. While a conventional rocket might roar for mere minutes, burning through its fuel in a spectacular display of power, our ion engines can whisper on for weeks, months even, ceaselessly accelerating us to speeds once thought impossible. It's a marathon, not a sprint, isn't it? They won't get you off a planet's surface, but once you're out here, floating in the glorious void, they're pure poetry in motion, perfect for those long, quiet voyages between worlds, or just nudging a wayward satellite back into its balletic orbit. The faint engine hum is almost a lullaby, a constant whisper as we glide through the velvet dark. You barely notice the subtle shift in gravity, a gentle pull forward as we gather speed, inch by inch, mile by endless mile. And the theoretical speed? Well, imagine a particle accelerator, only scaled up to propel a ship. The possibilities stretch into the infinite, almost to the very speed of light itself. The recycled air stirs gently, carrying with it the faint scent of ozone from the silent machinery. Starlight glints off the control panels, a silent tapestry of distant suns. But what if we could go even faster? What if we could cheat the cosmic clock entirely? Now, lean back and let your mind drift. Imagine not just bending space, but folding time itself. We're talking about something bordering on the mythical, a whispered legend known as the Krasnikov tube. It's Clarkatech, a marvel that currently lives only in our dreams and equations, reliant on materials we've yet to discover, if they even exist. Normally, if you sped through space at near light speed, time would slow down for you, relative to those left behind. A decade might pass on Earth, while you'd only experience a year on board. A strange thought, isn't it? But the Krasnikov tube proposes a shortcut, a kind of ripple in the cosmic fabric left in the wake of a very fast ship. A subtle distortion that allows a second vessel, departing much later, to somehow catch up through this temporal anomaly, arriving at the exact same moment as the first. Why does the universe always offer such tantalizing riddles? The gentle vibration through the hull is a reminder of our steady journey. Yet your thoughts race far beyond our current velocity, into realms of pure speculation. Think of it. A ship launches in 2090 towards a distant star, Epsilon Eridani, 10 light-years away. Then, 9 years later, in 2099, another ship could follow its wake, and both would arrive at Epsilon Eridani in the year 2100. It suggests a constant flow, a cosmic expressway where ships could depart monthly, forging an enduring, instant connection between star systems. Of course, creating a two-way tube, allowing for return trips. Well, that's where the physicists start to get headaches about causality. Messing with time is never simple, is it? The shift in gravity is barely perceptible, a gentle sway that reminds you of a ship at sea, not one adrift in the infinite ocean of space. But let's pull our thoughts back from the edges of paradox and look at another ingenious way to dance with light and motion. Far less theoretical, yet equally breathtaking in its ambition. Beyond the hum of our own engines, imagine a different kind of whisper, one carried on the purest light. You've heard of solar sails, vast, delicate sheets catching the gentle breeze of a star's photons. A laser sail takes that concept and supercharges it. Instead of relying solely on a star, we could unfurl a sail, thinner than a breath, and focus an incredibly powerful beam of light directly onto it. A concentrated push of pure energy, a photon hammer driving us forward, even from light years away. This allows for a smaller sail to achieve immense thrust, and that beam, it doesn't have to come from a star at all. Imagine a distant comet transformed into a miniature fusion power plant, broadcasting its focused energy across the void, extending our reach indefinitely. Isn't that just like space? Always finding a new way to surprise us. But a laser sail can do more than just push. That focused beam can also be absorbed by panels or rectennas on our ship, directly charging our systems, running everything from the navigation computers to the galley's espresso machine. The temperature inside the cabin is perfectly constant, a comfortable cocoon against the frigid vacuum outside. But you can almost feel the heat of those imagined lasers pushing us onward. And with that energy, we can ignite our own propellants, superheating them or ionizing them, creating a powerful jet of plasma, combining the best of both worlds, light-speed energy transfer and robust, directed thrust. This might mean trading a little bit of ultimate velocity for quicker acceleration, a faster sprint out of the gate. But imagine the possibilities for refueling, using a matter beam in tandem to replenish our fuel tanks from afar. The soft vibration through the hull seems to synchronize with these thoughts of grand voyages, a steady rhythm against the silence of the cosmos. And here's a clever trick. Just as a laser beam can push us forward, we can also use our own propellant to fire asterisk against asterisk an incoming beam, creating a braking effect. This is how we could gently guide massive comets into a star system, vaporizing their ice with an external beam to create a reverse thrust. Or, upon arrival at a distant star, if they've set up a laser array, it could act as a giant cosmic brake, slowing us down without us having to expend a single drop of our precious fuel. Clever, pure genius. Picture it, a network of light guiding us in and out of systems. You might need a moment to just float here, letting the vastness of these concepts wash over you before we dip into the next marvel. And then, there are the sails that dance with the very breath of a star, the magnetic solar wind sails, or magsails. Forget delicate sheets of mylar. These use invisible, powerful magnetic fields generated by superconductors to interact with the ionized particles constantly streaming from a sun. Think of it as catching the solar wind, not with a physical net, but with an electromagnetic one. We expand this field, a vast, shimmering bubble of force, and the sun's furious outflow of plasma, its solar wind, pushes against it, gently, inexorably, driving us to incredible speeds within a solar system. This magnetic field can be shaped, expanded, or contracted, allowing us to accelerate, decelerate, or even maneuver with graceful ease, surfing the stellar currents as if on an endless ocean wave. The starlight, reflecting on the curved surfaces of our observation dome, casts long, gentle shadows, making you feel utterly connected to the vastness. And the beauty is, the galaxy itself is not a perfect vacuum. It's filled with these whispers of energy, these pockets of ionized matter, waiting to be harnessed by such a magnificent design. The ship moves with a subtle, almost imperceptible sway, as if responding to unseen currents in the void, a silent affirmation of these profound possibilities. The deep hum of our life support systems is a constant, reassuring counterpoint to the quiet wonder of the universe outside. As you drift, suspended in this recycled air, the faint thrum beneath your seat, a constant lullaby, you might ponder the sheer ingenuity of reaching these distant stars. Our journey, after all, isn't just about getting there. It's about how we dance through the void. Perhaps you glance over at the softly glowing console, its lights reflecting in the endless dark beyond the viewport, and a thought arises about the many clever ways we've learned to coax our vessels through the cosmic ocean. Some of these ideas are truly magnificent in their ambition, born from the very fabric of physics itself, like the one whispering to us now, a quiet promise of velocity. Imagine harnessing a furious, high-speed gust of ionized gas, a solar wind made tame, perhaps even accelerated to your bidding. This isn't just a whisper of an idea. It's the heart of something called the magnetoplasmatic thruster, or MPDT for short. It's a rather grand name, isn't it? Picture currents of plasma, guided by the unseen hand of electromagnetic forces, propelling us not with a roar, but with a steady, relentless push. The soft vibration through the hull subtly shifts as the drive adjusts, a whisper of power humming through the ship's skeleton, a constant reminder of the journey. While simpler ion drives are a dependable workhorse, the MPDT aims for a more exhilarating pace, a true sprint through the darkness. It swallows ionized gas, from humble hydrogen to the more exotic xenon, with a particular fondness for lithium, which seems to coax out its best performance. The subtle hum you feel is the chamber at work, where the raw Lorentz force, an elegant interplay of electric and magnetic fields, coaxes atoms into a furious dance, pushing our ship forward. Yes, those internal components might wear down over time, a common struggle with such powerful energies. But isn't that just like space, always demanding a little maintenance? It's a power-hungry beast, certainly, needing vast reservoirs of energy to truly sing. You might even feel a barely perceptible drift, a tiny nudge in your equilibrium, as those invisible forces take hold. This makes it less ideal for tiny probes or small satellites, lacking the robust energy infrastructure we enjoy. But for a ship like ours, bristling with reactors and a dedicated crew capable of minor repairs, it's a small price to pay for such elegant momentum. It truly opens up the galaxy for exploration, offering velocities that verge on the interstellar far beyond a leisurely planetary cruise. In theory, this invisible hand could fling us through the cosmos at over 100 kilometers per second, though in practice, we usually settle for a little over half that. Still, even that speed transforms interplanetary travel from a crawl into a brisk stroll, and it kisses the very edge of what we consider viable for interstellar leaps. The gentle chill of the recycled air across your skin is a comforting contrast to the cosmic furnace outside. Yet inside, we generate our own miniature suns for propulsion, and unlike some of its electric cousins, the MPDT actually offers a decent shove, meaning we don't spend decades merely getting up to speed. It's a gentle acceleration, yes, but a persistent one. Now imagine an entirely different approach, one that playfully sidesteps the very rules of rocketry. Instead of carrying all our fuel, what if we were pushed asterisk? This is the clever concept behind matter beaming. Picture a distant, stationary beacon, perhaps an orbital giant, firing a continuous stream of accelerated particles at our ship. Much like a laser sail harnessing light, the sheer momentum transferred could provide not only propulsion, but quite ingeniously, even refuel us. Think of a beam of oxygen, not just pushing us, but also replenishing our breathable air. A dual purpose. Isn't that neat? Of course, the universe always has its little complexities. Firing a stream of charged particles across vast distances isn't as simple as it sounds. These ionized atoms, all carrying the same electric charge, have an unfortunate tendency to repel each other, causing the beam to spread out too quickly, losing its punch. It's like trying to push a string, but human ingenuity, as always, finds solutions. Perhaps specialized cargo pods, rather than microscopic particles, could be launched. We might catch these in a vast net or decelerator array, or they could vaporize near our hull, their scattered atoms gently pushing against a designated plate. The quiet hum of the environmental controls remains constant, a counterpoint to these wild ideas. Regardless of the focusing trickery involved, matter beaming holds a distinct advantage over pure light sails once we're moving at significant interplanetary speeds. Light, for all its speed, offers a subtle push, but a concentrated stream of matter can deliver a far more substantial, sustained shove. It's a parallel concept to beaming energy, where photons carry power, but here, the very atoms themselves are our engine, a constant, ethereal hand guiding us. Then there are the truly audacious ideas, concepts that border on the fantastical. Imagine the Medusa drive, a wonderfully dramatic name for a propulsion system that flips a well-known nuclear pulse drive on its head. Instead of having a pusher plate behind the ship to absorb nuclear detonations, you position a colossal sail, almost like a parachute, in front of you. Connected by an impossibly long tether, the nuclear charges detonate within this sail, pushing it forward, and in turn, it drags the entire ship along. Nothing to worry about, probably. The faint hum of our own engines almost sounds like a sigh in comparison to such a concept. This ingenious setup means the powerful detonations can happen far ahead, perhaps in higher, safer orbits, gently tugging the ship out of a low-gravity well. It offers a cleaner, theoretical exit from planetary systems, leaving the immediate environment undisturbed by the explosive forces. You might need a moment to just float here and ponder the sheer audacity of it all. Nuclear power, not pushing from behind, but pulling from the front. A strange, beautiful reversal of expectation, a dance with controlled chaos in the heart of the void. Now, let's step back to something a little more familiar, though still wonderfully clever: the microwave electrothermal thruster, or MET. You know how microwaves heat your morning nutrient paste? Well, imagine applying that same principle, but on a grand scale, inside our ship's propulsion system. We use microwave energy to superheat a propellant gas, igniting it into a plasma, much like an arc-jet rocket. It's all about using electricity to turn a simple gas into a jet, providing thrust, the gentle shifting of gravity within the ship. A subtle rocking motion is almost imperceptible as we continue our journey. This electricity, the very spark of our momentum, might come from our internal reactor, or from solar panels, or even be beamed to us from an external source, an invisible thread of power stretching across the void. The MET is generally considered a step up from simpler resistojets, offering a more efficient kick, though perhaps not quite the raw power of an arc-jet. It's a sturdy, reliable performer in the electrothermal family. What it lacks in sheer thrust or mind-bending efficiency, it makes up for in beautiful simplicity and, crucially, its appetite. The MET can quite happily munch on water as its propellant, and as you gaze out at the countless glinting stars, each a distant sun, you remember how abundant water is throughout the cosmos, tucked away in icy comets, within asteroid belts, even lingering in nebulae. It's a humble, versatile engine, promising long journeys with easily replenished tanks. Why does the universe always provide such elegant solutions, hidden in plain sight? But then, our minds drift towards the truly speculative, two concepts that push the very boundaries of what we understand about reality: negative mass propulsion. This is a catch-all term for any drive that harnesses the elusive properties of negative mass. Imagine matter that, instead of contracting space around it like normal mass, actually causes it to expand. Or, stranger still, imagine if you pushed on it, it would accelerate towards u, not away. A curious thought, isn't it? Since we've never actually detected this mysterious negative mass. Any technology built upon it, like many proposals for warp drives or wormholes, remains firmly in the realm of what we fondly call Clarkitech, magic, indistinguishable from advanced science. The subtle movement of the ship, a barely discernible sway, reminds us that even with all our current marvels, we are still bound by familiar physics. The theoretical variations of how negative mass would behave are as numerous as the stars, dependent on whether it's negative inertial or gravitational mass, active or passive, or some fascinating combination. Yet, in most common discussions, the core idea is simple. Positive mass would attract both positive and negative. You simply float here for a moment, letting the vastness of the void cradle you, before we consider something truly peculiar, a whisper of a concept from the edges of our understanding: negative mass. Imagine, if you will, particles behaving entirely contrary to our instincts. Where regular matter pulls together, two pieces of this negative stuff would simply push each other apart, a gentle, constant repulsion. But here's where the cosmic dance begins, isn't it? When a positive particle meets a negative one, they play a strange game of tag. The negative mass would subtly draw itself towards the positive, while simultaneously nudging the positive mass away from itself. This creates an eternal chase, one forever pursuing the other, the very basis for a reactionless drive, effortlessly propelling a vessel without a trace of exhaust. Why does the universe always do this to you? it's simply elegant. And speaking of subtle forces, picture a vessel moving with the silent grace of a ghost through the stars. Here, the hum of our own engines is barely a whisper, yet imagine propulsion so discreet it leaves virtually no trace. This is the realm of a neutrino rocket. Neutrinos, those tiny, fleeting particles, are famous for their indifference. They can slip through an entire planet as if it were empty space. If we could only harness them, directing their ephemeral energy from our stern, our ship would glide. No heat blooming in our wake, no thunderous roar, just a steady, cool push. This concept, for now, remains a profound dream, a quiet marvel. Such a drive would not just be silent. It would transfer almost no heat to its surroundings. A truly ethereal way to travel, don't you think? Almost like being part of the void itself. From the ephemeral to the epic, let's contemplate moving something truly immense, a dead star. Yes, you heard that right. Imagine guiding a cold, burnt-out white dwarf across the interstellar medium. This is the audacious concept behind a nova drive, or its even grander sibling, the supernova drive. It sounds like pure fantasy, doesn't it? The method involves delicately feeding hydrogen to the inert stellar remnant, coaxing it with immense precision into a tiny, controlled nova. Not a destructive explosion, but a small, engineered stellar flare, providing just enough thrust to nudge the star itself. A star for an engine. Can you imagine the sheer scale? A testament to cosmic ambition, certainly. Now, let's return to the more tangible heart of our journey. Feel the faint, reassuring vibration beneath your hand as you lean against the console, a subtle hum permeating the recycled air around us. This quiet power originates from a core concept, the nuclear electric ion drive. At its heart, a fission or fusion reactor, a contained miniature sun, diligently converts its raw energy into the electricity that breathes life into every corner of our vessel. It warms our chambers, illuminates our displays with their soft, shifting lights, and sustains our very existence. From that abundant energy, the excess is then channeled into our ion thrusters, accelerating charged particles, creating that gentle, persistent push, a steady, unyielding force, propelling us onward through the quiet void, almost imperceptibly. Imagine, if you will, holding a tiny, contained star in the palm of your hand, radiating with incredible power. This is the essence of a nuclear light bulb drive, though it's far more sophisticated than simply shining light. Inside, a gas core fission reactor burns at truly astounding temperatures. This immense energy is contained by a special quartz wall, transparent to the fierce ultraviolet photons it emits. Rather than letting that intense light escape, we channel it. It's absorbed by a precisely chosen propellant, which then rockets out the back at incredible speeds, perhaps 30,000 meters per second. That's a serious push, far beyond any chemical rocket, allowing for efficient journeys between planets. A brilliant, contained core of power, carefully controlled for our gentle journey. Nothing to worry about, probably. Now, for a concept of propulsion that feels a little less subtle, perhaps a touch more energetic. Picture a ship driven forward by rhythmic, controlled detonations. This is the nuclear pulse drive, best known in its Orion drive variation. Imagine small, precise nuclear charges exploding behind us, their immense energy slamming into a massive, sturdy plate at our stern, aptly named the pusher plate. This powerful shove, rather than violently throwing us forward, is then absorbed and smoothed out by colossal springs, They compress with the initial impact, then slowly extend, translating that rapid, incredible force into a more modest, continuous acceleration for the ship. A steady thrumming, a deep vibration through the hull, a sustained push across the void, turning thunder into a gentle glide. But the ingenuity doesn't stop there. Consider another approach, known as the Medusa variation. Here, the blast isn't absorbed directly by a stern plate, but by a vast forward-facing sail. This sail, enormous and resilient, then transmits the impulse rearward to the ship through a long, elastic tether, like a giant, cosmic slingshot. Each detonation provides a powerful impulse, which the tether then gently, rhythmically translates into our forward motion. The sheer power involved, harnessing the might of the atom, yet delivered to us with such an elegant, almost cushioned rhythm. Isn't it fascinating how we learn to tame such immense forces for our quiet travels among the stars? The deep, resonant thrum beneath you isn't merely engine noise. It's the very heartbeat of our vessel, a series of precisely timed, gentle nudges pushing us ever onward. You might feel a faint, almost imperceptible tremor through the deck plating, a soft vibration that whispers of incredible power harnessed with delicate control. Imagine, if you will, miniature suns blooming harmlessly behind us, each a tiny fusion event, a controlled whisper of the stars themselves, propelling us through the velvet dark. It's a marvel, truly, how we ride these miniature explosions, their modest power accumulating into the steady momentum that carries us across light years. Wouldn't it be incredible to perfect that, to find a material that could truly reflect all that raw energy, doubling our stride with each pulse? A dream of perfect efficiency, perhaps. The universe has a way of inspiring such grand visions, doesn't it? As those rhythmic pulses fade into a more constant, deeper hum, you feel a subtle shift in the ship's internal temperature, a comforting warmth radiating from the unseen heart of our nuclear thermal propulsion system. It's a quieter power, a continuous push rather than a series of shoves. Deep within the core, much like a grounded reactor, a controlled fission process superheats a stream of propellant, sending it blasting out behind us in a silent, luminous plume. The air you breathe, recycled and carefully conditioned, carries no hint of the raw energy contained just beyond the hull. A testament to the meticulous engineering that keeps all that fiery power precisely where it belongs. It feels utterly stable, doesn't it? A steadfast companion for the long hauls between planets. This steady drive, this contained inferno, makes the vast stretches between worlds feel almost manageable. You know, out here, far from any planetary shield, the vacuum is mostly just that, empty, save for the whisper of cosmic radiation. We're well protected, of course, cocooned in layers of shielding. But imagine using a system that just vented its own radioactive exhaust near a bustling spaceport or an inhabited moon. Impossible, isn't it? That's why the closed-loop systems, like ours, are paramount, ensuring only clean, superheated gas propels us. Perhaps one day, even these mighty engines will be commonplace for launches from Earth's high orbit. Nothing to worry about now, though. We're just comfortably drifting, watching the distant starlight reflect softly on the console lights. Sometimes, amid all this advanced propulsion, it's worth remembering the most fundamental principles. Even with these incredible drives, the very act of burning, whether for a quick maneuver or a gentle course correction, requires a breath of sorts. You might occasionally catch a subtle, almost subliminal scent of exhaust, a ghost of chemical combustion in the recycled air. It's a reminder that even the most advanced rockets still rely on a simple truth. A fire needs an oxidizer, its own kind of oxygen, to truly ignite. That brief, familiar puff of water vapor or carbon dioxide, the exhaust trail of our smaller thrusters, is a universal signature, whether from a starship or a simple plane back home. Isn't that just like space, always bringing you back to the basics, even as you gaze at distant nebulae? But then, you envision the ultimate journey, beyond even the reach of current dreams, powered by something truly ethereal, light itself. Imagine, for a moment, if our ship didn't push with gas or pulses, but with pure photons, a silent, blinding beam of light streaming out from our stern, a flashlight drive propelling us to speeds unimaginable. You might even feel a tingling sensation, a phantom vibration from the sheer potential asterisk of such a force. To convert mass directly into light, perhaps from exotic matter, or even the slow evaporation of a tiny black hole, to capture frozen light in perfect mirrors and release it as a silent, continuous push. The concept is breathtaking, isn't it? A whispered promise of near light-speed travel. Such a drive would promise speeds tantalizingly close to the ultimate cosmic limit, shrinking the vastness of the cosmos to mere years instead of centuries. Yet, for all its elegant simplicity, the energy demands are truly astronomical. An entire kilogram of pure photons, an almost unthinkable amount of raw energy, far beyond what any earthly battery could ever dream of holding. It makes you wonder, doesn't it, how we'd ever truly achieve such a feat. For now, the pragmatic truth is that even if we had such a light-speed engine on board, for most interplanetary sprints, we still get more oomph by using that energy to superheat a tangible propellant like a stream of hydrogen. It's slower, certainly, only a fraction of light speed, but sometimes a powerful, steady shove beats a whisper of light when you're just commuting between worlds, feeling the subtle shift in gravity as we glide. We drift deeper now, past whispers of starlight, and you might gently wonder how we keep moving. A silent vessel gliding through the endless expanse. Sometimes it's about a clever trick with the stars themselves. Imagine, if you will, the elegant concept of a nuclear light bulb drive, a notion so beautifully simple it almost sounds like a cosmic lullaby. Instead of carrying mountains of heavy fuel, we'd simply draw in the abundant hydrogen floating between the planets, heat it with a powerful, contained miniature sun inside the ship, then expel it with incredible force. A gentle yet mighty breath, powered by the very elements surrounding us. Isn't that just like space, always offering solutions if you know where to look? But sometimes, the universe whispers of something even stranger, something without a visible push at all. That's where the idea of a pitch drive comes in, a truly wondrous, almost magical notion. No expelled particles, no fiery plume in our wake, just a subtle shift in the fabric of space itself, an unseen hand guiding our vessel. Perhaps it's a field, a gentle force creating an imperceptible pressure difference, coaxing the ship forward as if on an invisible tide. Imagine a sphere of theoretical negative mass, a tug from the impossible, or simply a shimmering ripple of energy, making the void itself push us. Clarkatech, they call it technology so advanced, it feels like pure wonder. Nothing to worry about, probably. You feel the soft thrum beneath your seat, a barely there vibration that reminds you we are, indeed, moving. That momentum, that steady push, comes from something we call propellant. It's simply anything we intentionally release from the ship's stern to nudge us forward. Often, it's the contained, fiery exhaust of fuel meeting an oxidizer, a brief, beautiful supernova in our wake. But sometimes it's more refined, a focused stream of charged ions, or even particles of pure light photons coaxed into existence by an antimatter reaction. The faster we can fling those tiny particles out into the void, the more efficient our journey becomes. Imagine accelerating light itself, or even the ghostly neutrinos, to propel us through the cosmos. And speaking of those charged particles, let's consider the pulsed inductive thruster, or PIT. It's an ion drive, yes, but a rather elegant one, far removed from the loud, clanking engines of old. Instead of fragile electrodes that wear away with time, it uses an ingenious dance of magnetic and electric fields. You wouldn't hear a roar, perhaps just a faint, almost imperceptible asterisk, thump thump asterisk, every few seconds, as a tiny puff of gas, maybe even recycled air from the cabin, or collected Martian carbon dioxide, is sprayed into a flat coil. Then, for mere microseconds, a powerful surge of thousands of volts ionizes it, transforming it into a whirling plasma. The ship's gentle vibration might subtly shift as the Lorentz force takes hold, grabbing that plasma and flinging it out the back at incredible speeds, tens of kilometers per second. It's remarkably versatile too, almost omnivorous for propellant, capable of using anything from water to exotic gases. A quiet, adaptable heart for our long journeys, isn't it? Now, let's lean back into the comfortable recycled air and ponder something truly profound, something that almost defies belief, yet whispers at the very edges of our understanding: the quantum vacuum thruster, or Q thruster for short. You gaze out at the inky blackness, seemingly empty, a perfect void. But what if it isn't truly empty? What if the vacuum itself is teeming with activity, a constant, flickering dance of virtual particles, popping in and out of existence in an instant, like tiny, ethereal fireflies on the hazy edge of reality? This isn't science fiction. It's the Casimir effect, an observed phenomenon, and it's rather beautiful in its strangeness. Imagine two perfectly flat, conductive plates, brought incredibly close together, mere nanometers apart. In that impossibly narrow gap, certain virtual particles, those with wavelengths too large to fit, simply cannot appear. This creates an imbalance, a subtle pressure from the normal vacuum outside, pushing inwards, where the quantum dance is freer, a gentle, imperceptible force, born from nothingness itself. And here's where it gets truly mind-bending. If we can harness that subtle pressure, that difference in the quantum foam, we might be able to generate energy, or even particles, seemingly out of nothing. Imagine a silent, constant stream of photons or neutrinos appearing from the very fabric of space and propelling us forward without carrying a single drop of fuel. It sounds like perpetual motion, like magic, a gentle push from the universe itself, perhaps violating all the rules we thought we knew. Clarkatech, indeed. The soft glow of the console lights reflects the distant nebulae in your eyes as you process this. It's a concept so strange, so beautiful, it makes you question everything. You might need a moment to just float here, letting that idea settle as we drift silently through a cosmos that's far stranger and more wonderful than we can possibly imagine. The faint hum of the ship, the subtle shift in gravity as we navigate, all part of this quiet, impossible journey, powered by the very emptiness around us. Why does the universe always do this to you, just when you think you understand? As you drift here, the soft glow of your console lights reflects in the vast, inky canvas beyond your viewport. A faint, rhythmic hum from the engines provides a comforting backdrop, a quiet assurance in the deep silence of space. The recycled air, ever so slightly cool against your skin, reminds you of the gentle enclosure of your ship, a cozy haven amidst the endless expanse. You might feel a subtle shift in gravity, a whisper of movement as the vessel adjusts its course, a barely perceptible tremor through the hull. Sometimes, when we gaze out at the furthest reaches, we dream of engines capable of truly immense feats. Imagine a device so powerful it could command the very fabric of the cosmos, a quasar drive. This isn't just about moving a starship, it's about orchestrating the dance of celestial titans. Picture it, harnessing the unfathomable energy of a black hole, perhaps one you've gently coaxed into existence, or even a natural giant. Around this cosmic maw, structures would hum with magnetic fields, feeding it precisely to generate power beyond comprehension, much like the luminous heart of an actual quasar, that dazzling beacon, brighter than entire galaxies. This raw energy then propels something truly monumental. With such power, your vessel could achieve a significant fraction of light speed, a leisurely stroll across galactic distances. But the quasar drive's true marvel lies in its ability to grip a galaxy itself. Imagine attaching it to the supermassive black hole at the core of a star system, or even deploying many throughout. You could then, quite literally, drag an entire galaxy, coaxing it across the void. Think of the sheer audacity. You might even counteract the universe's ceaseless expansion in a vast region, allowing civilizations to stay connected across unimaginable distances. Isn't that just like space, presenting challenges so grand they demand equally grand solutions? Yet, the everyday reality of space travel faces a more fundamental challenge. You feel it in the quiet push and pull of your ship. Every time we move, we push something away. Newton's third law, a stern but necessary guide, dictates this constant exchange. For us to go forward, something must be expelled backward. Our propellant. This is the engine's exhaust, the very essence of traditional rocketry. Those particles, flung out at incredible speeds, carry momentum, and by conserving that momentum, your ship gains its own forward thrust. But this also means you must carry immense amounts of fuel, a heavy burden that requires even more fuel to accelerate. It's what we affectionately, or perhaps exasperatedly, call the tyranny of the rocket equation. On a planet, you simply push off the ground, the Earth itself, providing your reaction mass, albeit barely nudged in return. An aircraft uses the very air it flies through. But here, in this perfect vacuum, there's nothing to push against. This is why the idea of a reactionless drive whispers of pure science fiction, almost Clark-tech, a propulsion system that moves your ship without expelling anything. It feels like magic, doesn't it? A dream of effortless glide, untethered by mass or velocity limits. No more vast tanks of fuel, just pure, unadulterated motion. It's a concept that tantalizes, suggesting paths to destinations we can only barely imagine, freed from the most stubborn constraints. Bringing us back to something more tangible, something you might find quietly working away in the background of many orbital outposts, is the resistojet. This is a subtle marvel of electrical engineering, a tiny heart of warmth in the cold vacuum. It channels electricity through a simple resistor, much like the glowing filament of an old-fashioned light bulb. That incandescent heat then warms an inert gas, perhaps just a simple, harmless vapor, transforming it into a gentle stream of propulsion. It's not flashy, not a warp drive, but it's dependable. Resistogits are the silent workhorses for those delicate course corrections, the gentle nudges that keep satellites perfectly aligned.